Alright, boys and girls, welcome back to the third installment of our math-related video learning. So today I'm going to do a quick quiz review for our quiz on Tuesday on area and perimeter. Let's get started. So perimeter is the distance around a shape, or to put it differently, it's the sum of the side measurements of a shape. So what that means is to figure out the perimeter, we have to add up the distance all the way around a shape. So I've also put the formula of a rectangular square. We went over this in class, but if you add up the length plus the length plus the width plus the width, then you'll get the distance all the way around. And that's the formula right here that we usually use for a perimeter. Now, more of a sophisticated version of that, because we have two L's for two lengths, that's the same thing as length times 2. So another way of writing this is to say length times 2 plus width times 2. And so I've solved for this rectangle here, and we end up with a perimeter of 24 centimeters. This is a really good way of writing it, by the way. Once you get to high school, they'll have you sort of using the syntax, so it's a good idea to get started with that now. So area is the measurement of the space that something takes up, or of the surface of a shape or object. So in this case, my shape is a rectangle. Again, I've used the same measurements. This time use green. So the formula for a rectangular square is area equals length times width. So that's really simple for us. You just take the length, or the longest side, and multiply that by the shorter side, the width. And in this case, 8 times 4, we get 32 centimeters squared. So I think we all have a pretty good understanding of that so far. Now, as we went over when we came up with how our quiz was going to look, the fourth question on our quiz is going to be an algebra question. So we've gone over algebra a little bit. It's the study of symbols used in mathematical equations. So I have a sort of a more complicated example here that has to do with triangles that you really won't have to know until high school. So put my little thumbs up emoji here. All right, we can substitute the letters for numbers to solve equations. So in a much simpler way, that's what we'll be doing for that fourth question. So here, as an example, let's solve this equation. 3 times not sure equals 27. So we have to find out what number multiplied by 3 will give us 27. There are a bunch of strategies we can use, and we went over this in class. If you want, you can pause the video now and try it for yourself. Did you get 9? If not, that's okay. We'll review some strategies that we shared in class right now to review how this equation can be solved. So the first strategy, and one that I find to be the simplest sometimes, is division, pardon me. So when we have the equation 3 times, again, not sure, equals 27, it's actually the same thing as 27 divided by 3. So I put 3 different ways of figuring that out that we've gone through this year. One would be starting with our number in the middle and sharing smaller numbers to each side. So in doing this one, just to review, I would share 5. I would share another 5, so now I'm at 10. I would share another 5, so now I've shared 15. The next, I don't think I'm going to be able to share 5s anymore, but I can share a smaller number like 2. So I'll share a 2, now I'm at 17, another 2, 19, another 2, 21. Now I'm going to share some more 2s. So now I'm at 23, 25, and finally 27. So I've been able to evenly share all of 27 into 3 sections. And what did I get? Well, when I added up, I got 9 in each of those sections. So 27 divided into 3 sections gives us 9. Here again, I did our standard sort of long division. It doesn't end up very long for this equation, but I'll review that as well. So how many times would 3 go into 2? Well, it can't go into 2, so you could put an imaginary 0 up here if you wanted to. Well, how many times does it go into 27? If we're pretty comfortable with our multiplication table, then we can say, well, we know that 9 times 3 gives us 27. We do the subtraction and we find out that there's 0 remainder left over. The last one, the grouping, or kind of the chocolate chip cookie method, I like to call it. You share dots into each circle one at a time, and you count the dots as you do it until you get to 27. So in this case, when you do that, you end up with 9 chocolate chips for each cookie. All right, so the next method is the trial and error or multiplication table strategy. I sort of group these two together because the trial and error method, as we'll see, often uses the same sort of strategy, but you usually start with a higher number. So some students, when working on this, they wrote out their entire multiplication table until they got to the correct answer. So in this case, 1 times 3, 2 times 3, all the way up to 9 times 3. Sorry, I realized I flipped it after a while, but that's okay. So again, that's the correct solution there. So if you're doing the trial and error, then you might know that, well, I know 3 times 5 is 15, so that's too low. Maybe it's 3 times 7, and you might try that out and find out that it's 21, still too low. You might try 3 times 8, and then finally 3 times 9 to get your correct answer. The last two strategies we'll talk about are related to the other ones. So skip counting, similar to multiplication, or writing out your multiplication tables. If you skip count, and we can use sort of some of our patterning terminology here. Each term, as you skip count, once you finally get to number 27, that term will be the answer. So that's term 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the solution is 9. And as I sort of mentioned earlier, if you know your fact families, then you might already know that 27 divided by 3 is 9, and 9 times 3 is 27. All right, you made it to the end of this video, which means you've successfully reviewed for our quiz on Tuesday. If you have any questions, definitely come and talk to me. But I think we should all be pretty ready to go. I hope you've had an awesome weekend, and thank you so much for watching.